Hello and welcome to this tutorial on using Influent Advisor in GPSX. This video follows the tutorial presented in the GPSX tutorial guide on pages 36 to 40. We are going to characterize an influent based on the average historical data shown here. We will do this using the GPSX Influent Advisor tool, which is built into the software. This data will be used as direct input as well as targets while adjusting some unknown stoichiometric ratios. Let's start by making a new GPSX layout by selecting the New option from the File menu. Let's select the carbon-nitrogen library and then drag a wastewater influent icon onto the desktop. We can now save this layout by going to the File, Save As menu and selecting a folder of your choice and saving the layout name. Here I'll be using the name Tutorial 3. The next step in the process is to click on the Simulation button and move to simulation mode. A model will be created, although in this case it's only the influent object. We are going to start by creating a new scenario called Influent that will allow us to make changes to the parameters in the Influent menu. Now that that's complete, we can access the Influent Advisor menu. We right-click on the Influent object and select Composition Influent Characterization, which brings up our interactive menu. It's divided into three parts: the User Inputs section, which accepts the data, the state variables, which show the calculated values, and the composite variables, which also shows the calculated values that come from the influent model. In the User Input section, we will enter in as much information as we can about the influent concentrations. We do have data on COD, TKN, and ammonia, so let's enter those directly into the Influent Advisor menu. You'll notice that because we are entering this as part of a scenario, that the values in the menu are shown in green. Now that we've entered the data, let's take a look at the concentrations that are predicted by the rest of the influent model. The COD value that we entered is shown as 365 milligrams per liter as we entered it. However, some of the other values differ slightly, such as the TSS, which is slightly less than the 210 from the data that we have. The BOD and the VSS are also slightly off from the numbers that we have in our recorded data. The soluble COD number is actually quite large, and the soluble TKN number is out as well. This means that we will have to make further adjustments to our influent characterization by adjusting the stoichiometric fractions that are now currently left at the default values. Making these types of changes is a common task in influent characterization. If we click on the VSS number, Influent Advisor will show us the equation that is used to calculate that value and highlight the values in the table that are currently being used. The stoichiometric ratio shown highlighted here is the particulate COD to VSS ratio. Also shown here is the VSS to TSS ratio. Now we have enough information to calculate those ratios, the VSS and TSS numbers, as well as the soluble and total COD. The VSS to TSS ratio is a straightforward calculation using the numbers from the table. We can calculate the particulate number by subtracting the soluble from the total, and then taking that as a ratio over the VSS. These numbers can be entered directly into Influent Advisor. Once that is done, the remaining calculations are then automatically updated. So let's take a look at where we stand. Since we are shooting for a VSS of 168, we are still a ways off. In fact, we're a little further away than we were before. So let's click on VSS and see what else is involved in that calculation. We can see here that the particulate COD number is 273. We know from our earlier calculations that we want it to be 323. So let's click on it to find out how we can make that adjustment. We note that soluble COD is part of the calculation. Let's click on soluble COD to find out how we can make that change. we can see that there are two fractions that are available for us to adjust. So let's start by adjusting the soluble inert fraction of the COD. Let's enter a value of 2% here. And we can see that that brings our particulate COD up a little bit to where we want it to be. Since we don't really want to lower the soluble inert fraction too much more, let's work with the other fraction, the readily biodegradable fraction, and lower that to 15%. That's now got us up a little closer to where we want to be. So let's make another further adjustment. Let's make it 10%. It's moving more COD into the particulate side. And that's done the job by bringing us to the 323 number. The TSS and the VSS are now also in line. The only thing left is to make adjustments to the soluble TKN number to bring that up to 31 milligrams per liter. So by clicking on that, we can see that there is a fraction available to be adjusted, and it is highlighted here on the left. So let's start out by entering in a value of, say, 0.8 to see if that will get us where we need to be. So we've actually overshot it. So let's go back and try 0.85 and see if that brings us to 31 milligrams per liter. That's fairly close. Let's just make one last adjustment to 0.84, and that brings us to where we need to be. So to summarize the entire process of influent characterization, you start by entering in the data that you do know directly from the measured data you have. You can often get further information by calculating a series of stoichiometric ratios from the information that you have. And then lastly, making adjustments to some ratios that you don't have information for directly, but that you can adjust while matching a target concentration. Lastly, I'd like to highlight that if you do enter a number that makes no sense at all and doesn't allow for proper mass balance of your data, Influent Advisor will highlight problematic numbers for you right away. And by clicking on those numbers, you can determine which input parameters need to be adjusted to solve the problem. Thank you for watching this video. If you're interested in information on our other software products, such as CapDebtWorks for preliminary design and costing, ToxChem for industrial wastewater treatment modeling, or WattPro for drinking water treatment modeling, you can visit our website at www.hydromantis.com for further information.